Hey YouTube, I just wanted to make a quick video, my first video, about a project I think is really cool. I recently bought an Amiga motherboard from a Facebook marketplace sale, and I got it for relatively cheap, about $40. It wasn't working when I got it, so I fixed it up. Turned out to be a memory issue. And I've got this motherboard, and I'm thinking about what I can do with it. What kind of a case could I get for it? Looking at eBay, as you probably know, these Amiga cases, just the cases, the keyboards, anything, they're so expensive right now. Buying an Amiga 500 case for this with keyboard would cost almost as much as the computer itself. So I decided to look at other possibilities. One of them was obviously the A1500, the Checkmate A1500 case. Beautiful case, but a little out of my price range. Although this project, it adds up over time, so I'll get to that. So after fixing the Amiga 500 motherboard, testing it out, I was looking around for some possibilities, some solutions for this, and came across a great project by a gentleman on the internet known as Jason Beer, and it is for an Amiga EATX, Amiga 2000 EATX motherboard that you build yourself. He's got excellent instructions up on YouTube, or on GitHub, I should say, and the full bill of materials, how to assemble it. And as you probably know, the Amiga 2000 and 500, they're virtually the same computer. The only difference between the two computers is that the Amiga 2000 has an additional processor on it, an additional chip on it, the Buster chip, which is used for the bus control. I think Buster actually stands for Bus Master. And it allows you to use the Zorro 2 cards on the Amiga 2000. So I went about making this project, and I want to show it to you today. So this is the beast right here. The aesthetic I've gone for is, your period near correct beige tower. I think there's a lot of benefit to having the beige tower. You've got your 3.5-inch drive base here, and I've fitted it with a GoTech and a zip drive. And then you've got four 5.25-inch bays. I've got an IDE CD-ROM, a floppy drive that's been modded to work in an Amiga, and then two more drive bays that I'll figure out what to do with at some point. I'm gonna find a nice Amiga case badge. I'll put that on there. But yeah, this machine works really well, and it's running very stably. You can see right here, and I'll go into a little bit about what's inside. Okay, so I've turned the light on the phone, so there's a little bit of reflection there, a little glare, but you can see the motherboard, the Amiga 2000 EATX motherboard in there with the Amiga 500 chips transplanted into this case. It's got the RGB to HDMI card, and that's the slot there working for the 2000. And then the processor, I've swapped it out for a PiStorm running EMU68. And all that is working wonderfully. What you get on this board, and you can kind of see it in the background there, is it can support different versions of the Agnes chip and can support up to 2 megabytes of memory on board. I'll get into the memory chip on this board. It's probably the most difficult part of the assembly. But everything else, it works just like an Amiga 2000. You'll see I have only one Zorro 2 slot in there right now. There's the CPU expansion port or slot, and then here's the Zaro 2 slot, and in there I've got a networking card that's working great, and you can see just below that card the Bluster chip, which I've recently built because, like I said, the Amiga 500, it's the only chip that it does not have because it doesn't have any Zorro slots on it. So I built a few of those chips, Buster replacements. This project's called Bluster, also available on GitHub, Works, Charm, and I need to populate the rest of those Zaro 2 slots. I've actually got another card right there, or another connector right there. So this is the Amiga 2000 EATX GitHub page that Jason's put together. And it's a great page. It's got everything you need to put one of these together yourself. It goes through the entire bill of materials. This is an image of the PCB. Obviously, that's the first place you're going to need to start. You're going to need to get yourself a PCB for this. There's a very active Discord channel, and there's people in that channel or server that will that are ordering these boards now. So chances are you can find someone that's either in the middle of ordering some or has a couple available. If not, I've seen them on eBay. They go for kind of inflated prices. People are trying to make a few bucks on them. But you should be able to find one. If not, I guess try to get one printed at your favorite PCB manufacturer. Yeah, so I mean, the support for this is wonderful. I've thrown a lot of things at it right now, and everything seems to work just great. I have not used my 68030 card in here yet. I will give that a shot. I've got what is it, a 2090 SCSI controller. Oh yeah, right here, 829. I've got one of those. I'll give that a shot. I've got a PiStorm in there, the RGB to HDMI. I plan on adding a Buddha IDE card in there. Those are good value for money. I'm going to hook up that zip drive and the CD-ROM drive to that. Potentially a few other things. Yeah, so this is kind of the board that I've got, this purple one. And what you can see here, I'll open it up in a different tab, is you'll see that everything on here is surface mount. So you're going to have to become adept at surface mount soldering. The biggest challenge for me was this chip right here, the RAM chip. It's got the tiniest little pins on it, and you can't really make out the detail in this picture, but they are minuscule, and doing that with a soldering iron is next to impossible. So I ended up buying myself a hot air rework station for this project to get that chip on there, and that's worked out well. What I did is use a little bit of solder paste, and then put the chip in place with tweezers and hit it with the hot air until it stuck down firmly on all the pads. But even after that, I had some issues when running the diag-ROM test, and I had to go through and hit every pin with a hot soldering iron very carefully again. And I had to do that with pretty much all of the surface mount chips just to be safe. I actually had some issues with these chips up here, even though they look a lot bigger than they are really. They just weren't making the full contact that they needed to. So you got to be very careful there. Let's see. So here's his, I guess, a test rig getting set up. What it looks like in his machine in an ATX case. Oops. You've got the bill of material on here, and it's extensive. I mean, there's a lot of pieces here. I ordered mine from DigiKey, and it took forever for all the pieces to get here. And there's a lot of options in here too. You can use different types of oscillators, PAL or NTSC. This kind of socket mount one, the 4-pin one, or the surface mount one. This board can support multiple Agneses. I'm using a 1 meg Agnes, but you can use the 2 meg Agnes. It requires some soldered jumpers on the motherboard front and back to configure your Agnes, but you should be able to easily undo it if you decide to upgrade your Agnes to the 2 meg variant. And you'll see here the jumpers on the back of the board too. The tick header, I guess that's for syncing the video to an external source. I've never used one. Let's see, you can use different size ROM chips in here, so he's got instructions for where to align them to. Floppy drives, an internal and external header on here. Works great. Real-time clock, like he says, there's 2 options. You can get the original chip, the 6242. And that's what I ended up getting, actually. It was easier to find and cheaper to find some of these 6242 chips. I ended up buying like 5 of them just because they were so much cheaper and easier to find than the 62423A. So and it works great. I mean, it keeps perfect time. Let's see, he's got the whole DigiKey part list, and there's a ton of parts here. You can see all of the components, tons of little resistors and capacitors, and all the different 74 series logic chips, all the card edge connectors, etc. Yeah, and like you said, it is like a game of Where's Waldo when you're trying to find where to put some of these things. He recommends going through the KiCad files. I just took my time and I was patient with it. Yeah, I mean, I thought the board was laid out well enough, with clear enough symbols on it that it was pretty straightforward to put together. And he goes into, the individual components that are on here and does a good job of explaining those, I think. Some of these 74 logic chips that I bought, it was difficult to find out the orientation, so just be careful of some of those. The only one that I only blew one chip on here, and it was a 74 logic that I just didn't know the orientation of, and it popped on me. That was the only issue that I had. Besides when I was playing with it, popping one of the fuses on the motherboard that caused the mouse and the key joystick to go. Yeah, so he pretty much goes through everything, and it's a very comprehensive site. It's a challenging build. It took me a long time to put this together. Like I said, it's there's a lot of pieces on here. It's a full, complete Amiga motherboard. But very rewarding. This is my favorite Amiga system at this point, and I got a few of them. I got a couple of 500s. I got a Chicken Lips 500. I got a 2000 that I've kitted out as well. But this is my daily driver at this point. Thanks everyone for watching my video. I didn't quite get into the build of this project. I might do another video to kind of go through some of the difficulties like I talked about with that RAM chip, and maybe some of the tools that I used to do this build. Maybe I'll record some of the when I add some more of those sockets and fix the fuse that I had blown on the board. The cost probably ended up being about $250 all in. I got this case for like $7. I mean, it's nothing spectacular, as you saw, at an auction site. All the parts from DigiKey were probably around $200, and then I paid about $40 for the Amiga 500 motherboard. So, Your mileage will vary, I'm sure. Well, thanks everyone again for watching this video, and I will see you next time.